A bullet of mass small m is flying horizontally and strikes a body of mass capital M, which is suspended by two identical threads of length L. The bullet gets embedded into the body. As a result, the body along with the bullet swings upwards and the thread deflects through an angle theta. Given that small m is much less than capital M, we have to find the velocity of the bullet before striking the body, the fraction of the bullet's initial kinetic energy that gets converted into heat. In order to solve this problem, let us begin from the moment when the system has already swung upwards to the maximum angle theta. At this point, the combined mass small m plus capital M is momentarily at rest. This means that all the kinetic energy that the system had just after the collision has now converted into the gravitational potential energy. The vertical rise in the height of the system is h is equal to L into 1 minus cos of theta. So the gain in potential energy is small m plus capital M times GL into 1 minus cos theta. This must be equal to the kinetic energy of the combined mass immediately after the collision. Let the velocity just after the collision be capital V. So we write small m plus capital M times GL into 1 minus cos theta is equal to half small m plus capital M into capital V square. If I cancel small m plus capital M from both the sides, I get GL into 1 minus cos theta is equal to half V square. If I solve this equation, I get V as root over 2GL into 1 minus cos theta. Now let us analyze the collision itself. The collision happens in a very short time. During this time, gravity and tension act vertically, so they produce no torque about the point of suspension. Therefore, the angular momentum about the point of suspension is conserved during the motion. Before collision, only the bullet of mass small m is moving with a velocity small v at a perpendicular distance L from the pivot. So the initial angular momentum is L initial is equal to m into small v into L. After collision, the combined mass small m plus capital M moves with a velocity capital V at the same distance L. The moment of inertia of the combined mass about the pivot is I is equal to small m plus capital M into L square, and the angular velocity omega is equal to capital V by L. So the final angular momentum is L final is equal to I into omega is equal to small m plus capital M into L square into V by L, which turns out to be small m plus capital M into L into capital V. By conservation of angular momentum, we get m into small v into L is equal to m plus small m into L into capital V. Now if we cancel L and if we solve for this equation, we get small v as capital M plus small m divided by small m into capital V. We already found that capital V is equal to root over 2GL into 1 minus cos theta. If I substitute this value of capital V into the previous equation, I get small v as capital M plus small m divided by small m into root over 2GL into 1 minus cos theta. Now since small m is much less than capital M, we approximate small v as nearly equal to capital M by small m into root over 2GL into 1 minus cos theta. If I simplify this equation by using some trigonometry, I can write 1 minus cos theta is equal to 2 into sine square theta by 2. If I substitute this value of 1 minus cos theta in the above equation, I get small v as capital M by small m into root over 2GL into 2 sine square theta by 2. If I solve this equation, I get v as nearly equal to twice of capital M divided by small m into root GL into sine of theta by 2. This is the velocity of the bullet before impact. In order to find out the fraction of kinetic energy that got converted into heat, I'll have to write down the initial kinetic energy of the bullet first, which I can represent as Ki will be equal to half into small m into small v square. The kinetic energy of the system just after the collision can be represented as Kf will be equal to half into small m plus capital M into capital V square. Using the relation mv equal to small m plus capital M into capital V, we get kF by Ki will be equal to small m by capital M plus small m. This is the fraction of energy that remains as mechanical energy. Therefore, the fraction of energy that got converted into heat is 1 minus kF by Ki, which turns out to be capital M by capital M plus small m. And this is the answer for my second part.